Hi Twitch, and welcome back. I am Abby Fuller. We're here with our coverage live from the expo floor at reInvent in Las Vegas. Cool session coming up. We're going to pack a lot of stuff in all at once. So we're going to be looking at 3 different new instance types. Gentlemen, can you introduce yourselves for us?
Sure. Hi, I'm Sudhir Raman. I'm a product manager in Amazon EC2 with an interest in general purpose and memory optimized instance families.
Hi, I'm Vishwesh Sahasravade. I'm a product manager in EC2 networking.
And hey guys, this is Chetan here. I'm also a product manager with EC2. And I'm part of the team that manages our accelerated computing instances. They have GPUs and FPGAs for applications such as machine learning and high performance computing.
Okay, awesome. So let's start off with the A1s and Sudhir. Can you tell us a little bit about the A1 instances in general?
Sure. We recently launched the Amazon EC2 A1 instance, which is our first general purpose instance powered by the all-new AWS Graviton processors. And these processors are custom designed by AWS, and they feature cores based on the ARM architecture.
Awesome. Can you tell us a little bit about ARM?
ARM is essentially a specific architecture for the processor. It's a processor architecture technology, and it has a pretty broad ecosystem with support for a wide range of software, including several open source software tools that our customers use.
Awesome. What are some examples of applications that customers would want to deploy on these A1 instances?
Yeah, so A1 instances are well suited for scale-out workloads and ARM-based applications as well. For example, if you have applications that you can spread across multiple cores and you can fit them within the A1 memory footprint, those would be ideal candidates for utilizing the A1 instance. Some examples of applications include web tier, containerized microservices, distributed data stores, caching fleets, and in addition, customers that are and developers across the ARM ecosystem would find these instances appealing because now these developers have access to scalable, elastic ARM hardware in the cloud.
Awesome. A question from Twitch. Trying to understand Nitro, are all EC2 instances now running Nitro?
Several new EC2 instances are now running Nitro, and that's the direction we are headed going forward.
You kind of just answered this, but someone from Twitch wants to know, the A1 instances, what workloads would you expect to run on these? And I think you kind of got into there with the applications, but...
Yeah, so for the most part, we believe scale-out workloads are a good target. And if your applications are typically using open source technologies, those tend to run well on multiple processor architectures, partially and mainly due to support that is offered by the Linux distributions for these multiple architectures.
What are some of the key benefits of the A1 instances that are making them the right choice for those kinds of workloads?
The key benefits, they're threefold. First one is lower cost. So with the A1 instances, applications that can run ARM instructions can get up to 45% lower cost on for the workloads for our customers. Secondly, customers can get the flexibility and choice of a new processor architecture in the cloud. And with these new A1 instances, the capabilities that our customers are most familiar with, such as ENA, EBS with elastic block storage, as well as all the ARMs, these capabilities seamlessly work on the A1 instances.
Awesome. Sudhir, thank you. We might pop back to you if any other questions from Twitch show up for you. Let's move on to the C5n instances with Vishwesh. Can you tell us a little bit about the instances that you launched last night?
Sure. Last night we announced the C5n instances. This is the first cloud-based instance that provides 100 gigabits per second of networking performance to a single instance, available today in 5 regions.
Can you tell us a little bit about what kinds of workloads or applications would benefit from this increased networking performance? Because that's a really high throughput.
Sure. We were the first cloud that provided 25 gigabits of performance 2 years back. Many customers, many applications took advantage of this and scaled out efficiently. However, we've seen certain kinds of applications that could benefit from even higher performance. So first thing that comes to mind is high performance computing applications. A lot of our computational fluid dynamics, weather simulations, crash simulations. They can scale out much more efficiently with higher performance, higher networking. You've also got big data applications like Hadoop, etc. that need to download lots of data for processing. And the faster you can download the data, the faster you can process. So they can benefit from these kind of applications. And then there are network-bound applications like firewalls, routers. The faster you can go, the faster they can process packets, the faster they can drive performance. These are kind of applications that can benefit from C5n.
So before we jump into my next question, Twitch wants to know, is Graviton only for AWS clusters? Is it DPDK compatible? I don't know who wants to field that one, or not at all.
So there are two different things there. Graviton is the compute processor that drives A1. We have got our own Nitro card that drives storage and network offload. In fact, a lot of the Graviton innovation came from being able to offload our storage and network. As part of that network offload, customers can use this DPDK, which can drive even better performance. So what they do is install these custom drivers, and for applications that can benefit from that kind of data access patterns, they can drive higher throughput, higher packet rate, and lower latencies. So
the A1 instances are essentially powered
It's okay.
powered by the Graviton processors, and as Vishwesh said, they're also built on the Nitro system, which provides the offloading capabilities.
Awesome. Another question from Twitch, is that 100 gigabytes a number that I can get consistently, or is that within an AZ? Is that something that I can consistently get?
absolutely. So C5n instances can drive 100 gigabits per second of sustained throughput. This is available within an AZ, between AZs, within a placement group. There are no constraints there. In fact, the best scenario where you can use it is actually driving downloads and uploads from S3, where you can drive a very high throughput and transfer data much faster.
Gotcha. Can you tell us a little bit about the performance differences between the C5Ns and the C5s?
So C5 was our first Nitro system-based instance type, launched last year. It drove 25 gigabits of performance, which, as I said, was excellent. We noticed two things that we could improve. They're obviously driving higher throughput, which was enabled by this 100 gigabits of performance. But there was also memory performance that we could improve, and we did that by increasing the memory by up to 33% on C5n instances. Many high-performance computing applications can benefit from this higher memory performance.
Awesome. So Chetan, on to you.
Yep.
You launched the P3dn instances last night. Can you tell us a little bit about those?
Absolutely. So P3dn instances are the new addition to our P3 instance family. They're the largest instance size. They come with the latest NVIDIA GPUs, 8 of them, each with 32 gigabytes of GPU memory. We have packed in a whole bunch of other features also. So the 100 gigabit networking connectivity that Vishwesh just talked about, we have brought that with our GPU instance. We have also increased our CPU performance, where we have 96 vCPUs, Skylake-based, with access to AVX 512 instruction set. We have increased the system memory, and we've also thrown in local, almost 2 terabytes of instant storage, NVMe backed. So super excited about this platform. It brings a lot of capabilities for our customers in the machine learning and the HPC space.
Twitch, by the way, is letting me know that I said gigabyte a couple minutes ago instead of gigabit, and I'm sorry, it's been a long day.
Yeah, it is. It should be gigabit.
They're really similar words. Okay. So I think we have another question from, no, it's not. There's something else. Oh, it's just a comment. saying 100 gigs from S3, what a time to be alive. And that is in fact true, what a time. How does higher network throughput improve performance for machine learning training kind of specifically?
Right. So in order to answer that question, let's rewind back about a year ago, right? So when we launched our first P3 instances, customers were able to very significantly lower the time to train their machine learning models, right? They were able to go from several days down to like hours. So that's great. Customers, really valued the developer productivity that they got by leveraging our P3 instances. And now, we don't want to stop there. Our customers are asking for, why does it take even hours? So why can't I train our models in some minutes, right? And that's where you start talking about distributed training. This is where you need multiple P3 instances working together to help train your model, right? So the 100 gig connectivity becomes super critical there for two reasons. One is each of these nodes or instances need to talk to each other to actually share training information. And they also want to access data at a really high throughput, right? So this is where the S3 connectivity that Vishvesh talked about again comes into the play, where you can source data in a high throughput fashion to all these nodes that in parallel are trying to process or trying to train your machine learning model, right? So again, it's all about just optimizing single node performance and coupling in distributed training via the 100 gig connectivity.
So I have kind of a general question for everyone, which is that we have a lot of instance types. Are there some hallmarks that customers should be looking for that can point them in the right direction of knowing that they're choosing, if not you can't always get the exact right instance type on the first try, but some general things that they can look for to make sure, to help them pick the right instance family maybe for the kinds of workloads that they're doing?
So let me jump in first on the networking front. One of the things that we do at Amazon is to build the technology and then provide it at scale to customers. So what that emphasizes here is we are providing this 100 gigs of connectivity, not just on C5n, we are already doing it on P3dn, and we are going to have more and more instance types come out with this capability. Our goal here is to have customers be able to choose the right kind of application and not be network bound. Now, going beyond that, there are obviously choices in terms of memory and CPU, and Sudhir can jump in on about how to choose between those.
Yeah, absolutely. I think our goal is to provide the broadest and deepest selection of instances across a variety of workloads that our customers run. So we have categories of instances, for example, for workloads that are the most compute sensitive, that need the highest single-threaded compute performance. We have the compute optimized instance family with the C-class instances. For workloads that are more, that need more memory, for example, let's say you're running an in-memory database application, or you're running high-performance databases. We have the memory optimized instance family with the R as well as the X-class families that scale. For example, the R5 offers 768 gigs of memory, and you can scale all the way up to our high memory instances that we launched with 6, 9, and 12 terabytes. So based on the sensitivity of the workload to compute memory or storage, we have a variety of options in our portfolio that our customers can choose from.
I think also what people don't always think about is that you're not stuck with one. You don't have to pick one and then it's well, I've chosen my instance family and then that is the end of the road for me. You can change things in your launch configuration. When something new comes out, or if you decide, okay, actually I think I need a little bit more memory that I didn't used to need, you can always change. I have a question also, which I think might be kind of a joke question, but they've asked it twice, so I think we're going to go for it, which is, we used to only have 3 character instance names, and now we've hit 4. How do you guys remember them and keep them apart, and how many characters are we planning to go to? And I have no idea, right? No one can predict the future on the number of characters, but eventually we'll run out of letters in the alphabet, and then I don't know.
Yeah, so I can take that, right? So, one of the feedbacks that we got from customers was that they want a simpler way to understand what they're picking. So it goes back to your previous question, right? So as Sudhir mentioned, we are compute optimized, we have a general purpose instances and memory optimized instances. And what from the feedback that we receive from customers are asking for unique capabilities on a per platform basis, right? So in order to help our customers easily differentiate and kind of pick out that platform, we have come to this naming nomenclature where we're adding these letters to help identify the specifics of that platform, right? So, for example, about a month ago, we launched our AMD-based instances, and those instances are marked by the letter A, right? Our network-optimized instances have the letter N. The ones that have local disk now have the letter D, right? So C5d, M5d, and P3dn, right? So that again is we just kind of responding to customer feedback, help them understand very quickly and succinctly, what capabilities are native to that instance, and what they can help refine the selections for their applications. Anything else, guys, you want to add?
No, I think that pretty much covers it.
Okay, sounds good.
So it sounds like hints from the letter, and then beyond that, you can kind of figure out what the difference is between the different members of that family.
Correct.
But you get a hint in the name.
Yep.
So can't speak to roadmap specifically, and I think this one might be for you, but can you talk to us a little bit more generally about what you think maybe is next for ARM instances?
So we introduced A1. It's our first generation of ARM instance with the Graviton processor. We expect to be able to essentially build and iterate based on direct customer feedback and essentially innovate on behalf of our customers, not only through our instances, but also through our underlying infrastructure as we've been doing. And going forward, I mean, we expect that there will be more ARM instances, but at the same time, we also have support across x86 with Intel and AMD, and we see that continuing as well going forward.
Awesome. I'm looking to see if we have any other questions for Twitch. Guys, if you have any other questions, we have just a couple of minutes left. So if you want to talk about an instance type, or if you want to ask them what their favorite instance type is, just in case we can get any of them to pick one.
We're going to be super partial to our instances, right?
I'm sorry?
We're going to be super partial to our instances, right? So anyway.
Okay, we'll just skip to the end and say that everyone chose their own instance. So Sufferless Computing on Twitch says, for general usage, which instance family would you suggest replacing with an A1 instance? So if I already have an existing instance type, what do you think is kind of, what is A1 the next logical jump for that instance?
Right, so we are currently positioning A1 as part of the general purpose family. So the ideal candidates would be workloads that are more in that general purpose space. And in terms of the specific requirements of the applications that you're running, we encourage you to test it out because if you're running open source applications, interpreted languages, say Python, Ruby, and Apache Web Server, those typically should work just fine, right? Whereas if you have dependencies on native code, that might require recompilation. Or if you're dependent on specific x86 instructions, then we have other options like the M's and the T's.
Yeah. So another question from Twitch, will AWS support TPUs at any point?
Sorry, what was the question again?
Wondering if we're planning to support TPUs at any point.
Great. So I think for ML applications, we're always looking at ways to bring additional value to our customers. The NVIDIA GPUs that we have in our portfolio currently provide a really great price performance for our customers. If you look at the time to train your models or the cost to train your models, we think we have a very compelling value proposition there, and we'll continue to innovate on behalf of our customers and explore different ways and opportunities to help optimize their time to train and cost to train. So.
And I think someone just mentioned it in chat, but at some point you need to look at your own workload to see what works well for you. Right. That it's not just like we make a recommendation and then if you're running machine learning, you can only use that instance type. Like, play around with it, find how much resources your actual workload needs, find the instance type that works right for you, test them out, try them with your own workload, and then kind of see where it takes you.
Right.
So I think this is like a Oh, so we have another question from Twitch, which is actually from Randall, who works at AWS. But we're gonna go with it because it's cool. How do T2 and T3 burstable types compare to A1? All the questions are for you today, by the way. I hope you're having fun.
Yeah, I'm definitely having fun. So they're targeted at, it's entirely workload dependent. For example, if your workloads have variable CPU usage.
Sorry. We're not closed. You can It's okay. We're good. They can still hear you.
So if your workloads have variable CPU usage with occasional spikes in demand, the T instances will still give you the best cost benefit. With the A1 instances, you get a fixed compute resource, and you get access to ARM-based instances. And for workloads that need consistent performance or fixed performance, you could evaluate A1 and see if that gives you cost benefits as well.
Okay, awesome. We are just about out of time. Twitch, thanks for joining me. Guys, thanks for coming on and talking about the new instance types. We are signing off for a couple minutes, and we will be back, I believe, with a recap in just a couple of minutes, so stay tuned, and thanks for joining.